They call those granules. What that is hot plasma. It acts like boiling soup. Here's a video of these. This is just slightly sped up, but this is a real video of the surface of the sun. Look at it. These granule things pop, and you get energy from that. Infrared light, the heat you feel from the sun. Ultraviolet, the ozone layer protects us against that. We get hit by gamma rays, I was showing you earlier. But also, this picture was taken from Earth looking through the atmosphere, which we talked about distorts the image, right? It's actually looping away from it. It's a dozen Earths tall, one coming at you. And that's what I was talking about earlier. Some of them that were stacked together in the background. That's kind of what we saw today. Look how violent the surface of the sun looks. That's one of my favorite pictures I've ever seen of the sun. About to talk about right there. That's a little bit of flare activity going on. We'll come back to heat. While that prominence is going up, you can see these magnetic fields twisting and turning. And right here, you can see them kind of poking up from inside of the sun. And this shows you the spicule layer. This is a video of the spicule layer. This is eerie looking to me. Look at this. Look at that. Watch this loop you get. Right there. I like that. You see those jets of gas shooting up almost 5,000 miles into space. You may have noticed a small flare that went off in the background with the right. Boom! I like that one. And see all those hot spots that I was talking about there? Now to show you, compare the difference here. Here's a prominence from last year. It took about 2 days for this. It kind of does cartwheels on the surface. So you see some of the gases kind of flipping this way, some flipping that way. After about 2 days, though, watch how that main cloud pushes out. That's what I was talking about earlier. It goes out roughly about 100,000 miles or something, a little bit less than that. Wow. See that? Yeah, see it dissipates as it gets out. And that's why they're referred to as weaker cousins of the flare, these prominent. Remember this one? Cool nebula. Those two areas of space are known as stellar nurseries. Have you ever heard that term before? Now you know what that means. That's a star factory. So what you're seeing right there, just around them basically manufacturing the star, then kind of sandblasted the cloud away. That's going to happen all throughout here too. See what's going on here? It's like a big recycling process that goes on out there in space. And like I said, you got a few billion years to go for it, or years in the back. Let me give you an idea how big that cat is. Our entire solar system, not the galaxy, just the solar system, the sun and all the planets, the big flat disk, with the sun in the middle, from one side of the solar system to the other, it's right about 10 billion miles across. You even got some of these pictures from there. If you ask Cindy at the front desk, the belt and the sword, that looks familiar to most folks. But here's the rest of the constellation here. That's Betelgeuse. There's a picture of it. That star is so big, they call it a super red giant. It's so big, if you shrunk the sun as it is today, down to the size of this ball, and wanted a ball the size of Betelgeuse sitting next to it, on this size scale, the Betelgeuse ball would be 2 of these theaters in size, sitting next to the sun. Now, this was taken from the Hubble Space Telescope, the Helix Nebula. Beautiful picture there. Look right in the bullseye, right there. That's the star that did all that. That is now a dead star. That's what they call a white dwarf star. No more nuclear fusion going on. It's just a hot core of carbon about the size of Earth. But it's still really, really hot where you can actually see it, even though it's small. And it makes all these gases glow with ultraviolet light shooting out from there. Now, dawn exposure shows a lot of color that we saw last night. But that's basically what it looked like, didn't it? And this is the main part we see in the telescope. But you can see, even over in this part, all these stars that are in these gases, very young stars that are born in there, making those gases glow. And here's the most famous Hubble telescope image ever taken. October 2003, that's when that big flare went off. There was a lot of activity that month. Now, some of these are the same nights, some of them are different nights, but even on the same night, you'll see different shapes because they kind of dance around the sky.